Hello guys, I'm going to solve a problem of moment of inertia for composite figures, and let me show you what the problem looks like. So this is going to be the problem that we have to do. We have this section which is part of a beam, a composite beam made out of these 3 planks, and we have to find I sub 0 x, so the moment of inertia with respect and y, that the centroidal moment of inertia, that means with respect to the centroid, and also kx, ky, and j0. Kx is called the radius of gyration with respect to x, ky radius of gyration with respect to y, and j0 is the polar moment of inertia. Okay, if you remember the formulas, remember I sub x in this case, if x is the centroid, is going to be the summation of all the I sub zeros with respect to the x-axis, or I sub 0 centroidal with respect to the x-axis of each one of the figures, plus the summation of the areas times a distance measured in y squared. A distance measured in y squared. The moment of inertia with respect to the centroid in the y direction is the summation of all the individual centroid moment of inertia of each one of the figures with respect to the centroid, plus the summation of the areas times a distance measured in x squared. Now the polar moment of inertia can be calculated by Ix plus Iy, and the radius of gyration is just the square root of I divided by A in the x direction, or the moment of inertia in the y direction is the square root of Iy divided by A. This is what we have to do. Now, the problem is asking us to calculate the moment of inertia of this beam with respect to its own centroid. We don't know where the centroid is, so in case that you haven't realized it, before doing the moment of inertia, we have to locate the centroid. And that means also that you have to be highly proficient in calculating the centroid, and don't waste time to that. So I'm going to put my axis of reference here for calculating the centroid. Why here? Because remember, I always say place the whole figure in the first quadrant and make all the distances positive, and then we have to divide these in individual figures. And if you remember, the formula for moment of inertia, center of gravity, or centroid, is just the summation of AI xi divided by the summation of the areas, or y bar is the summation of AI yi divided by the summation of the areas. Let's start with that. Let's calculate the centroid first. How do you calculate the centroid? Remember, figure, that's the first step. Figure, area, x, y, a times x, and a times y. That's our table for calculating the centroid. How many figures do we have here? Well, I see 3 figures. I could see 2 also, but that requires a little bit more of experience from your side, from your part. So I'm gonna say that we have 1, 2, and 3 figures. So this is figure number 1, this is figure number 2, and this is figure number 3. And when I say that I see 2 figures also, it's because I could combine these 2 in only one figure and say that I have 2, this and this, these 2 as one, separated like that. It is. You can practice that and you can see if it works, and of course it works. Now let's fill this table then. Fixing the camera. Okay, there you go. Now figure 1 is this one here. I'm gonna put my axis like I always do. Axis, and my figure 1 is gonna be somewhere here. Now, first of all, area. What is the area? This is 4, this is 1, so it's going to be 1 times 4. 4. I didn't put the units, but remember we have to put the units: inches squared, inches, inches, inches to the third, inches to the third. So this is 4. X, what is x? Well, every figure has a centroid. centroid for figure 1 is that one, and this x is the distance measured from my axis of reference to that centroid, meaning is the distance from here to there. This is 1, and this is placed at half of this base, which is also 1, so it's going to be 1 plus half of 1 is going to be 1.5. Now in the y direction, this is a rectangular area, so my center is going to be at half, at the center of that height, and the distance from here to here, if this is 4, this is going to be 2. Multiply this times this, 6, multiply this times this, 8. Figure number 2. Somewhere here, that's my figure number 2, this figure here. What is the area? The same area. That's what I told you, we could combine it because it's symmetric, everything. What is the x distance? Well, it's not 1.5, but the center is located here. So the x distance is going to be the distance of this centroid measured from this axis. This is 1, 2, 3, 4, 4.5. And at y is half of 4, which is 2, is going to be here. So 4 times 4.5 is 18, and 4 times 2 is 8. And last but not least, let me put a line here, last but not least is this figure. So I put my axis and I put my figure over there. What is this area? 2 times 6, 12. What is x? X is the distance of this centroid measured from my axis of reference. If the total is 6, half of the distance is 3. What about in y? Well, in y I have to measure from here to there. How do I measure from here to there? I know that from here to here is 4, and because this is 2, it's going to be half of 2 is 1, so it's going to be 4 plus 1, 5. And now we multiply 12 times 3, 36, and 12 times 5, 60. Now the formula says summation, well, summation nation, and summation of area, total area. We do the summation here, we add this is 20, this is 36, 54, 60, and this is 60, 76. Meaning my x bar is going to be 60 divided by 20, which is 3 inches. Remember, this is inches to the third, this is inches squared. And my y bar is 76 divided by 20. And that's 3.8 inches also. And that completes our calculation for the centroid. So far, up to this moment, we have accumulated a total of 0 points. Why 0 points? Because we are not asked for centroid, we are asked for moment of inertia and radius of gyration, polar moment of inertia. Now, next step is locate that centroid. It's going to be at the center. You see that we didn't even have to calculate this because we knew it was going to be at the center here. So that makes complete sense. Now this is 2, 3.8 should be somewhere here. I'm going to place there my centroid because this is 4, right? 4, and it's supposed to be 3.8 from here. Let's say that this is my 3.8. I know it's going to be a little bit higher. I'm just going to put it there. First of all, to see it makes sense. Yeah, it makes sense. And second, because I'm going to keep drawing and I don't want to be this point too close to that for demonstration purposes. That's it. Now, continue with this. What do we have to do now? Well, we have to continue with this formula. The area I have, but I need to add now this column and this column. So let's do that. I'm going to put this paper here just to continue the table. And I'm going to continue the table with a different color so you can see where we are stopping the problem. This is centroid. Now what I'm doing here is only for moment of inertia. What is the first thing that I need? I sub 0 x. Oh, but I also need I sub 0 y. So I'm going to put here I sub 0 y as well. And then I need the distance in y. That's not differential of y. Everybody say differential of y. A distance in x. That's not differential of x. And then I need a times distance in x squared. And I need a times distance in y squared. Why is that? Because then I have to do summation of this plus summation of this, and that's going to be my moment of inertia, and so on. So let's complete this table for this problem, and let's start here. This figure, figure 1, what is the moment of inertia of a rectangular area? Moment of inertia of a rectangular area. Nobody moves. I need my paper. Where's my paper? Here is my paper. Moment of inertia of a rectangular area. Here, there you go. 112 bh cubed. Okay, this is a rectangle. So if this is a rectangle, it's gonna be 112. I'm gonna just copy here. 112 bh cubed. Now what is b? B is 1. What is h? H is 4. 112 of 1 times 4 to the third. That's the value of this moment of inertia. That value is, I don't know, my calculator. 4 to the third divided by 5.3 periodic. This value, I'm just gonna put it here, is 5.3 periodic. I copy it like that so you can remember where it comes from and you can see it. Now I sub 0 y. What is I sub 0 y? Instead of being 112 bh cubed, you can see here that is 112 hb cubed. Why is that? Well, because it's basically, if we have this shape, let's say, I don't know, bh, and I want the moment of inertia in this direction, it's going to be bh cubed divided by 12. B base height to the third divided by 12 if it's a rectangle. Now, but if I put it like that and just rotating the axis, it's gonna be hb cubed divided by 12, because now h becomes the base and b becomes the h, and then you can see it like that with respect to x, with respect to y. It's like rotating the axis. That's it. So it's going to be 112 of h is 4 times b to the third. H is 4, 112 of 112 of 4, and h is 1 to the third, and this is equal to 0.33 periodic. 0.3 periodic. Now, careful with this one. What is dy? And I'm going to repeat that definition several times during this video and during all the videos that I'm recording. Dy is the distance, measuring y of course, between the centroid of my composite figure, which I'm going to call x0 and y0, is going to be the distance between, measuring y, between the centroid of my composite figure represented by this axis and the centroid of figure 1 in this case. The centroid of figure 1 is here, the centroid of the composite figure is here. Distance that I'm looking for is this. How much is that distance? Well, you can see the distance from here to here is 3.8 because we just calculated that, 3.8. And the distance from here to here is 2, so it's gonna be 3.8 minus 2, 1.8, 1.8. This distance. Now, dx, what is dx? Dx is the distance measured in x between the centroid of my composite figure and the centroid of figure 1 in this case. So the formula or the distance that I'm looking for is this one. How much is that distance? Well, from here to here I know there is 1, and from here to here is 0.5, so that should be the distance, 1.5. From here to here is 1.5. Now if you don't want to think, and I know a lot of you don't want to, you don't even have to think. The only thing that you have to do is, whenever you have to calculate the distance in y, you go, if you had the location of the centroid before, and you say 3.8 minus the distance in y for figure 1. So 3.8 minus 2, 1.8. Same thing with the distance in x, 3 minus 1.5, 3 minus 1.5, these two, 1.5. And that, you're gonna be that applies all the time. Now the only thing we have to do is multiply 8 times the x squared, 8 times the x squared, area is 4, we have it from before, times the x squared is this one, 2.25, that's 9. And 8 times dy squared, 8 times dy squared is 4 times 1.8 squared, that is 12.96. Units, I didn't copy the units, my fault. Units here and here and here and here are inches to the fourth. Here also inches to the fourth, because those are the units for centroid, moment of inertia. Now let's go to figure 2. Figure 2 is the same type of rectangle as this one, so this is going to be exactly the same thing. 1/12 of 1, 4 to the third divided by 12. I mean 1/12 of 1, 4 to the third, 5.3 periodic. Distance is y is going to be 4 times 1 to the third divided by 12. That's 0.3. Exactly the same centroidal moment of inertia because it's the same figure. Now distance in y. Well, as you can see, the center of this figure is at the same level of the center of this figure, so the distance from here to here, it has to be 1.8, and if you measure in this direction, it's going to be 1.5, same as the other one, 1.5, and this is going to be 9 because it comes from the same values, and this is going to be 12.96 because it comes from the same values again. Now, you want to check this out? Check this out. 3.8 minus y minus y. 3.8 minus 2, 1.8. Where's my, this is not 1.5, 1.8. Why didn't you correct me when I say that? 1.8, the same distance, 1.8. And in y is 3 minus 4.5. 3 minus 4.5 is 1.5. You're going to say, oh no, that's negative 1.5. Fine, negative 1.5, but I have to square it anyway. When I square it, it's going to be positive, so I don't care about that. This is the absolute value of that distance. I don't care the positive or negative sign. Now let's go to the next one. Now the figure is this one. Now it's going to be base. What is the base? 6 times, what is the height? 2 to the third divided by 12. 6 times 2 to the third divided by 12. 6 times 2 to the third is 6 times 8, 48. 48 divided by 12 is 4. This is the value here. For the other distance in y is going to be 2 times 6 to the third. 2 times 6 to the third divided by 12. H times b to the third divided by 12, and that is divided by 12, 36. And I don't know why I did that multiplication, because I could say, oh, 6 squared is 36, 36 divided by 12 is 3, 3 times 2 is 6, 6 times 6, 36, there you go. Now distance in y, let's say that I don't want to even bother thinking what is the distance in y. The only thing that I have to do is get this 3.8 and subtract this 5. 3.8 minus 5 is 1.2, and 3 minus 3 is 0. I know that I say that I don't care, but let's do the analysis of where these come from here. Look, distance in y is the distance between the centroid of the composite figure and the centroid of figure 3. I know what is this. This is 3.8 up to here. That means that if this is 4, this distance, this little distance is 0.2. And this is 0.2, and this other one is 1, so it's going to be 1.2, 1.2. Now, in the horizontal direction, the center of this figure and the center of the composite figure coincide. That means they are over the same axis. That's why you have this 0 here, and that's why it comes from 3 minus 3, 0. Now you multiply area, which is 12 times 1.2 squared. 12 times 1.2 squared, that's 17.28. And let me use the calculator for this because it's complicated. 12 times 0 squared. Okay, I was being ironic in case that you haven't noticed. Okay, now we have to do the summation here for this, and we're going to do for this and for this. What is the summation of this? Well, it's going to be 5.3 times 5.3 times 4. This is 10.6 periodic times 4 is 14.66. 14.6 periodic. What is the summation of this? 36.6 periodic. What is the summation of this? Summation of this is oh, look at that again, one more error. And that's good that this happens, you know. It's very good that this happens, because that's something that happens a lot during the program when you are solving the problem. This 0, and I was being ironic, and it took me, and this is not fake, I mean, I really made that error. When I put here, this is not AD squared, ADX squared. I copied this value, but this value is this, 17.28, and I hope that you catch that in the video. And this one in X is 0 here. So I just switched these two values when I was solving it, and be careful with that. It's a very good thing that happened to me. It's not a very good thing that happens to me on camera. Not that I care too much, but anyway, this is 18, these two, and then you add these two, 12.96 plus 12.96 plus 17.28, and that's 43.2. And now the reason I put this in circles like that is because another error, that is a silly error, but people want to add X with X and Y with Y, and this is not the case. You are adding X with Y. That's why I put this circle with this circle, and this square with this square. So I sub 0 in the X direction is going to be 14.6 periodic plus 43.2. and I sub 0 Y is going to be 36.6 periodic plus 18. Y with X, X with Y. Now this is this plus this is 57.82. It's not 82, it's 88 actually, because this is let's say 86 periodic inches to the fourth, and this is 36.6 periodic, 54.6 periodic inches to the fourth. This is just IX and IY. I hope that this is correct. Let me check it just in case. Yeah, 57.866666. Good. And the other one, of course, is 54.6. Okay, these are the values for this problem. Now, the other thing that we have to do is J. Well, J is extremely easy. J is just the summation. J sub 0. Now I'm gonna move this here, and I'm gonna say, okay, J sub 0 is just I sub 0 X plus I sub 0 Y, polar moment of inertia. So J sub 0 is going to be 57.86 periodic plus 54.6, and J sub 0 is 57.86 plus 54.6, 112.53 inches to the fourth. Remember this J4 that comes because when you do the I don't want to teach here theory because this wasn't about theory, but this comes from polar coordinates, and then actually J0 is the integral of this is the integral, the Ix is the integral of y dA, y squared dA, and x squared dA, and x squared plus y squared is r squared, and this is the integral of r squared d theta, the angle. So but it's the area, I'm sorry, but it's the same thing. Anyway, this is just this plus this. I'm gonna do another video explaining moment of inertia. Now Kx is going to be, as I said before, the summation, the square root of Ix divided by area, and Ix is 57.86 square root, and the area is 20, the total area we calculated before, and Ky is the square root of I sub y divided by a, which is 54.6 divided by 20. And remember, this is inches to the fourth and this is inches squared, so when you cancel these two, it's going to be inches squared. When you take it outside the square root, it's going to be inches. 57.86 divided by 20 and elevated to the 0.5, that's 1.7 inches, and 54.66666 divided by 20, and that's it, to the 0.5, 1.65. And that will conclude all the values that we were asked to calculate in this problem. Now, homework for you. What is radius of gyration? Not the formula. This is the formula. What would represent radius of gyration? If you wanna drive crazy your professor, ask him that question. Ask him that question. Radius of gyration. And if you want, you can explain it to me in the comments of this video. Radius of gyration. See you next time, guys. Enjoy. Remember your exam, and this my students' exam are coming really soon. So study. See you next video.